Okay, so we all think we know how a compass works, right? You pull it out, that little needle points north, and you're good to go. But what if I told you it's been lying to you this whole time? Seriously, today we're going to dig into a secret that has tripped up sailors and explorers for centuries.
So let's just get right to it. Why is your compass lying to you? And I mean, it really is. It's not because it's broken or anything like that. No, it's because it's following a set of rules. And those rules are way more complicated than you might think.
You see, that needle, it's not actually pointing to the North Pole, the one you see at the top of a globe. It's being pulled towards something else entirely. And figuring out that difference, well, that has been one of the biggest puzzles in the entire history of navigation. Okay, so to really crack this, we have to get our heads around a pretty wild idea. There isn't just one north. There are actually two of them. And even though they sound the same, they're completely different things. All right, first up, we've got true north. This is the one you know and love from every globe in every classroom. Think of the Earth spinning like a top. True north is that one single, unmoving point right at the very tip of the spin. It's fixed. It's our planet's permanent up, and it's the anchor for pretty much every map ever created. And then there's magnetic north. Now this is what your compass is actually paying attention to. It's hooked into the Earth's magnetic field, which, get this, is not a fixed point at all. It's actually wandering around. So if true north is this rock-solid anchor, magnetic north is a constantly moving target. So now we've got this fixed point and this moving one. What happens when you try to navigate between them? Well, the angle of difference between the two changes, depending on where you are on the planet. And this global difference has a name: variation. So variation is just that angle between true north and whatever your compass is saying. And the reason for it is, well, it's pretty incredible. Deep down in the Earth's core, you've got all this molten iron sloshing around, creating a massive magnetic field. It basically turns our whole planet into a giant, slightly wobbly bar magnet. But here's the kicker. That magnetic pole doesn't line up perfectly with the axis our planet spins on. And because of that little offset, the magnetic pole's a little different no matter where you are. And this isn't just some abstract theory either. Scientists can pinpoint the exact location of the magnetic North Pole. Right now, it's kind of meandering its way through the Canadian Arctic. And as it moves, it's dragging the needle of every single compass on Earth just a little bit off course. But hold on. It gets even more complicated. The Earth's magnetic field isn't the only thing messing with your compass. There's another problem, and this one is way closer to home. In fact, it's probably right there in your boat or car with you. It's called deviation. So, deviation is basically magnetic interference coming from your own stuff. Think about a boat or even your car. You've got a massive metal engine block, miles of electrical wiring, maybe some big speakers. All of that stuff creates its own little magnetic field, right? And that local field creates a distortion that can pull your compass needle even further off track. Okay, let's just pause and break this down. Variation is the big global one. It's caused by the whole planet, and it changes depending on where you are in the world. Deviation, on the other hand, is totally local. It's caused by the stuff on your specific vessel. That means you can look up the variation on a chart, but the deviation, that's unique to your boat, and you have to figure it out yourself. So, let's recap. The compass needle is getting pulled around by the Earth and by your own boat. It sounds kind of impossible, right? So how on earth does anyone actually navigate? Well, luckily, there's a really smart, centuries-old method for figuring it all out. It really comes down to 3 basic steps. First, you grab a nautical chart. That'll tell you the variation for your specific area. Second, you have to figure out the unique deviation just for your vessel. And finally, you do a little bit of simple addition or subtraction to correct your compass heading and find out where true north really is. And, sailors have had a handy little trick for this for ages. It's a simple rhyme. West is best, east is least. All it means is, if the variation is to the west, you add that number to your compass reading, best, as in, you make it bigger. If the variation is to the east, you subtract it, least, as in, you make it less. It's a really elegant little solution for a massive, planet-sized problem, isn't it? So, now we know the secret sauce. We know how to correct for both the Earth and our own ship to find out where we're really going. But let's be real. In a world full of satellites and GPS on our phones, does any of this old-school knowledge even matter anymore? Well, what we've just walked through is the fundamental secret of navigation. This whole dance between true north,
magnetic north, variation, and deviation, it's not just cool trivia. It is the absolute core knowledge that allowed humans to map the entire globe and sail across its biggest oceans.
And that leaves us with a really important question for today, doesn't it? We rely so heavily on GPS for literally everything, that perfect, magical signal from the sky. But what happens when that signal goes out? What happens when the screens go dark? In that moment, it's this fundamental understanding of the world's invisible forces that lets a real navigator find their way home.